Okay, so this is the last part of Unit 2 where we deal with the naming and formula writing for ionic and covalent compounds. You really will have to be able to not only write the formula of both types of compounds, but you're also going to have to name them. And this is a lot of information. It's also really, really important though, because when we get to reactions and other parts of this semester, you will have to be able to talk about compounds and name them with a very high degree of accuracy. So when we write a formula, we're going to use a subscript to talk about the number of atoms. So earlier in this unit we wrote water. There's 2 hydrogens here. It's an understood 1 for this oxygen. We typically don't write ones. I always say that it's because chemists are lazy. It's an understood for us. If you have something where there are more than one polyatomic ion, so for example here is sodium cyanide, we only have one of each. But if we were to have magnesium cyanide, where we need 2 cyanides, you would have to put parentheses around there to denote that this too applies to every atom in the parentheses. If we were to write it without, it would look like there's only 2 nitrogens and not 2 carbons, so that would be wrong. Now, covalent compounds are usually the easiest for people to understand. This is going to be 2 nonmetals, and when you have 2 nonmetals, you're going to use a series of prefixes. So you're going to name the first element using its element name, the second element by the root of the element name ending to "ide," and then you're going to add prefixes to indicate the number of each atom. The exception is you do not use mono on the first element. So for example, this is carbon monoxide, carbon dioxide. Typically, nonmetals can combine in more than one set, and so we have to specify using those prefixes. So here are some examples. We have carbon monoxide as CO, SF4, S we name with its element name, which is sulfur. Fluorine becomes fluoride, and this 4, we are going to use the prefix tetra to denote. So this is sulfur tetrafluoride. Here we have S2O4. We don't use mono up here on either of the first because there's only one, but if there's more than one on the first element, we have to use a prefix. So S we name as sulfur, oxygen becomes oxide, and then we go back to add prefixes. 2, we're going to use the prefix di. 4, we're still going to use the prefix tetra. So this is disulfur tetraoxide. Now guys, technically the prefix is tetra, oxygen should be oxide. Whenever there's 2 vowels, we typically get rid of one just to make it easier to say. My exams are multiple choice. You don't have to worry about these minor spelling issues. What you have to worry about instead are the spelling issues that could change the meaning. Like for the polyatomic ions, sulfate versus sulfite. That spelling error changes the meaning from SO4 2- to SO3 2-. But for things like this that do not change the interpretation of the compound, I'm not going to worry about that. You just need to make sure you are aware that if it's off by a little bit, that's probably why. What's the formula for dinitrogen pentoxide? Well, this is one of the easy ways, this is the easy type of compound to really interpret. Nitrogen is N, oxide came from oxygen, and we look at the prefixes to tell us how many of each. Di means we had 2 nitrogens, and pent means we have 5. Sulfur dioxide gives us S for sulfur. Oxygen is O. There's no prefix here, so there's only one sulfur. This di means we have 2 oxygens, so it's SO2. What's the name of PF3? Well, 2 nonmetals. So we're going to name the first element by its element name. So P is phosphorus. Fluorine becomes fluoride. And the 3, we're going to use the prefix tri here. We're not going to use a prefix here because there's only one phosphorus. S2F6, we're going to name it as sulfur. We need a prefix to say how many, so it's going to be a disulfur. Fluorine becomes fluoride, and the 6 indicates a hexa, so it's disulfur hexafluoride. Oops. Probably would have been a little bit cleaner if I had chosen to write further down, huh? Now, ionic compounds are different. With covalent compounds, we use prefixes. We don't do that with ionic compounds. Ionic compounds are going to be distinct sets of rules. Now, the first type of ionic compound is a metal from group 1, 2, or 3, not a transition metal, and some nonmetal. You're going to name the cation first using its element name. The anion you name second using its element name and changing the N to "ide." We don't have to use prefixes here because these guys are only going to combine in one set of ions, or one set to make a compound. So KCl is potassium chloride. If we were to look at why this is the formula, we could say, well, let's look at potassium and chlorine. Potassium has a charge of +1 because it's in group 1. Chlorine has a charge of -1 because it's in group 7. We only need one of each of these to give us a total positive and negative charge that cancel. And so we write this as K, we don't write the 1. Cl, we're not going to write the 1. So KCl is potassium chloride. That is the only combination that these atoms will combine in. MgO, we have magnesium and oxygen. Magnesium is a 2+ because it's in group 2. Oxygen's in group 6, so it's -2. They already cancel. Oops, how did I do that? You love when you learn something about technology. So these cancel, so we only need one of each. So we write it as Mg1O1. When I make my table, I'm going to use this set of columns every time, and I know that the subscripts come from this second column, the number column. So MgO is magnesium oxide. It won't combine in any other ratio because it wouldn't be neutral. Na2S, this is a group 1, 2, or 3 metal, so we name it by its element name, which is sodium. Sulfur becomes sulfide. So what's the formula for sodium phosphide? I'm going to make this table every time, guys. Number, charge, total. We have sodium, which is Na. Phosphide came from phosphorus. Oh, it's time to take a break soon. Sodium is in group 1, so it's +1. This is in group 5, so it's 3-. So we need to figure out how many of each of these we need to cancel and give us a neutral compound. And hopefully you can see we need 3 of these, 1 of these, to get a total positive of +3, a total negative of 3-. So this is going to be Na3P. I'm not going to write the 1. Calcium nitride, calcium and nitrogen. This is +2. This is 3-. We need 3 of these and 2 of these to give us the lowest common denominator, or the number that will cancel. So total positive, total minus are going to be equal. So it's Ca3 N2. What's the name here? We have group 1, 2, or 3 metal and a nonmetal. So we can just name it with the element name. So this is aluminum. Oxygen becomes oxide. KBr, K is potassium. Bromine becomes bromide. Just like that. It gets a little bit different if you have a transition metal. Because transition metals can have more than one charge, you have to specify the charge with a Roman numeral. So we're going to name it exactly the way we did before. You name the first element with its element name, but before you name the second element, you have to insert a Roman numeral indicating the charge. And then you name the nonmetal with the root of its element name ending in "ide." Here, for example, iron 2 chloride. Number, charge, total. We have iron and chlorine. We only have one iron, but 2 chlorines in this compound. Let's say we didn't have the name. We were trying to name it. If we know that chlorine is in group 7, so it has a 1 minus charge. It gives us an overall negative charge of 2 minus. To cancel, we need a positive charge of plus 2. Spreading over one atom gives us a charge on that iron of plus 2. So we name it as iron 2 chloride because the charge on the iron is a 2 plus. Manganese 2 oxide, the charge on manganese is a plus 2 here. Copper 1 sulfide, the copper has a plus 1 charge there. There are exceptions, so if you do practice, especially if you're going to Google or YouTube things that I haven't approved, be aware that you are going to need to know these extra rules. You will not be specifying a charge for zinc, which is always going to be 2 plus, or silver, which is always plus 1, and tin and lead are considered transition metals, and so you will do it for these the same way you would as for titanium and the other transitions. So what's the formula for nickel 1 oxide? Well, I'm going to make a table every single time. Atom, number, charge, total. So nickel and oxygen is from, or oxide comes from oxygen. It tells us the charge of nickel is plus 1. Oxygen is in group 6, so it has 2 minus. In order to cancel, we're going to need 2 nickels and 1 oxygen. Gives us a total positive of 2 plus, total minus of 2 negative, which will cancel. So nickel 1 oxide is going to be written as Ni2O. Remember, this is where the subscripts come from. This is where the name comes from for transition metals. All right, chromium 6 sulfide. We have chromium and sulfur. It tells us the charge of chromium is plus 6. Sulfur is in group 6, so it's got a 2 minus charge. So we just need 1 of these and 3 of these to give us charges that will cancel. And so we can write this as Cr1, I'm not going to write my 1, S3. What's the name of VO2? Well, we can't name this. We can say that this is vanadium. Maybe like that. And oxygen is going to be oxide, but we don't know the charge on vanadium unless we make this table. So we're going to make a table, and we know we have 1 vanadium, 2 oxygens. We know the charge on oxygen is minus 2, giving us an overall negative of minus 4, which means we have to have an overall positive of plus 4, or a charge on the vanadium atom of plus 4. So this is vanadium 4 oxide. Fe3N2. We have 3 irons, 2 oxygens. So we know this is iron nitride. We don't know the charge on iron, so we have to solve for that. Nitrogen is in group 5, so it's a -3 charge. It gives us overall a -6. To cancel and get our +6, the charge on each of the 3 iron atoms has to be a +2. So this is iron 2 nitride. Oops. Now, if you have a polyatomic ion, you're going to follow all the same rules as before, except here you're going to name the polyatomic ion by its name. So here we have potassium paired with carbonate, ammonium paired with chlorine. So we're just going to name it by the polyatomic ion name and name the rest as it according to the rules. This is copper and sulfide, so we would have to make the table number, charge, total, where we have 2 coppers, 1 sulfur. We know the charge on sulfur is -2 because it's in group 6. Gives us a total positive, has to be +2. Spread over 2 atoms gives us a +1 charge. So this is copper 1 sulfide. Okay, so what's the formula for manganese 5 peroxide? We have manganese. Peroxide is O2. Number, charge, total. Manganese 5 means it's got a charge of +5. Peroxide from your flashcards is going to be -2. To cancel, we're going to need 2 and 5 to get that lowest common denominator of 10 to cancel. So we're going to write Mn2. We can't write O25 unless we have this in parentheses. If we were to do it without those parentheses, it's going to look like 25 oxygens, which would not be good. Okay, so calcium cyanide. Calcium and cyanide. Calcium is in group 2, so it's 2+. Cyanide from your flashcards is 1-, so it's 1 and 2 in order to cancel these. So this is CaCN2. I'm only including the parentheses, guys, because there's more than one. Down here, ammonium doesn't have parentheses because there's only one ammonium. So the name of NH4Cl is just ammonium. Chlorine becomes chloride. This is ammonium. This ion is hydroxide, so it's ammonium hydroxide. Last little bit of naming. Acids are ionic compounds whose formula begin with an H. They are considered ionic because an H+ is going to be donated to solution. If you do not have an oxygen, you start with the name hydro. You name with the root of the anion's element name and end with ic acid. So HCl, there's no oxygen, so we begin with hydro. Chlorine, the root of that is chlor, ic acid, so hydrochloric acid. H2S, no oxygen, so you start with hydro. Sulf is the root of sulfur, ic acid, so hydrosulfic acid. Once you contain oxygen, usually those are from the polyatomic ions. These are called oxyacids, and you're going to use the name of the polyatomic ion to determine the name of the acid. So if you originally had an ion that ended with ate, now it's going to be ic acid. If it originally ended in ite, now it's going to be us acid. So H2SO4. SO4 is sulfate. Okay, there's an L there. So there's oxygen, no hydro. Sulfate becomes sulfuric acid. Carbonate is going to become carbonic acid. Sulfite, the sulfite ion, is going to make this sulfurous acid. Now, bases are just going to have the hydroxide in them, and you're going to follow the rules for naming polyatomic ions. So what's the formula for hydrocyanic acid? Number, charge, total. Hydro, because it's got acid, you're going to start with an H. Cyanic came from cyanide, so Cn. This is a +1 charge. You've memorized the cyanide because you have flashcards, so it's -1. You need one of each, so it's HCN. Calcium hydroxide. Ca hydroxide is OH. Charge of +2 because it's group 2. -1 because you've memorized it. You need one of these, two of these, to give us charges that will cancel. So it's got to be CaOH2. But remember, you need parentheses if you have more than one polyatomic. Phosphoric acid. Acid means it has an H in it. Phosphoric means it came from phosphate, which is 3-. So we need 3 of these and 1 of these to give us a charge that cancel. So it's H3PO4. This has got a polyatomic ion, no acid or anything like that, so we name it element name. So this is calcium, polyatomic ion is hydroxide. This has oxygen, so we need no prefix of hydro. Nitrate becomes nitric acid. NO2 is the nitrite ion, so it becomes nitrous acid. Now, guys, I have these things here to help you. I wonder if it's going to let me open it. All right, let me see if we'll just... The problem with naming, guys, is that there we go. All right, usually you have to be in PowerPoint slideshow to see these, and you should just be able to click it, but for some reason it's not letting me do it, which is great. All right, so here's what we're going to do. I'll open this in a minute, but before you log off, I would like to give you the activity that I give my face-to-face classes. The problem with naming is it is very easy to become overwhelmed, and the only way to really master it is to basically become so comfortable that you are sick to death of it, is how I usually say it. And so what I do is I give my students this set of problems, and I ask them to do it usually in class I have them work as groups, so it works best as groups. So I give them a set of atoms. Here I want you to write the formula and name of these combinations. So lithium, sodium, magnesium, and what nonmetals did I give? All right, so here's the first part. I don't want you to pair lithium with nitrogen and sodium with oxygen. I want you to pair lithium with nitrogen, then lithium with oxygen, then lithium with sulfur, then lithium with fluorine, and then I want you to do the same thing where you go all the way down and do as many combinations as you can for all of these. When you do that, you have the group 1, 2, or 3 metals with either binary or polyatomic ions. You have transition metals. Oops, too far. Transition metals. You have a polyatomic ion, and you're going to make some acids. That covers a lot. Now, it is a lot of work, guys, but by somewhere in the middle of this, typically students start to see the pattern. They may not have to make the table each time. It becomes much easier. And so we used to have a lab even where students would do 300 or so problems, and since we've rearranged the labs a little bit, we no longer do that. And so I just want to give it to you on your own. For these, give the name of CO, CO2, let's move that one. And the last set was give the formula for oops, I didn't do that when I did this. Okay, so I ran out of room for this one, so this is all one compound. Now, let me see if I can pull up. There we go. All right, so guys, if you open this link, what'll happen there we go, is you should get a nice little flow chart. I have two. I have one for formula writing and one for determining the name. So if the compound starts with an H, it's going to be an acid. And so you then look, well, is there an oxygen? No, well then you name it with the root of the element name, ic acid. If there is an oxygen, you have to look at the polyatomic ion. If it originally ended with 8, it's going to become the root of that name, ic acid. If it was originally ite, it becomes us acid. If there's no H, you can then see, well, does it start with a metal or a polyatomic ion? If not, it's covalent. You're going to use prefixes. If there is, you're going to name it. You then need to consider if there's a transition metal. If not, you name the cation with the element name, root of the anion's name, ide, or with the name of a polyatomic ion. If there's a if there is a transition metal, use your Roman numeral to indicate the charge. These little sheets are meant to help you really succeed with the way you understand naming. And so just try to do this as much as you can until you are basically sick of it. Okay? And good luck. I will try to post answers to these soon, but it would also be a good idea to talk about it in the help forum.